All right, I want to go over some of your homework problems. Specifically, number one, but we'll go over number two as well. So I want to make sure that we're all on the same page in terms of figuring out, how many numbers are in a sequence and how to use Gauss's method to calculate sums. Now we did this. This was the topic of discussion in class on Thursday. So we did some of these things on Thursday, but let's go over them. So looking at this first one, we're just trying to figure out how many numbers are in the sequence. So and I'm saying I'm not asking for the sum, so you don't have to add them up, but just tell me how many numbers there are. So for this first one, obviously this list starts at 1 and ends at 68, and you're increasing by 1 each time. So if you were to count up the numbers, it would be 1, 2, 3, all the way up to 68. Clearly there are 68 numbers on that list, right? So the first one, hopefully you wrote down 68, okay? The second one's a little bit trickier though, because we're still increasing by 1, 5, 6, 7, all the way up to 110, but they're not going to be 110 numbers on this list because we're missing the first 4, right? So we have to subtract off those first 4. So you could kind of visualize it like this. So we're looking at 5, 6, 7, and how far did we go? 110, I think? 110, yeah? So 108, 109, 110. If you're trying to figure out how many numbers are on that list, you could kind of visualize it like this. You could say, well, I'm missing these first 4. Okay, so the number of numbers on the list should be, well, if I look at the entire list, including the stuff in blue ink, then it would be there are 110 numbers on that entire list. But the first 4 were not on my original list, right? 1, 2, 3, 4. So I need to subtract off the first 4 numbers. And so that comes out to 106. So you should have gotten 106 for the second list. A common mistake that students will make is they'll say, oh, well, it's this number minus this number. So they say 110 minus 5 and get 105. But that's not quite right. You're not missing the first 5 numbers, you're only missing the first 4 numbers. So it's this number minus this number minus 1, right? So like 5 minus 1 is 4, so it's this number minus 4, okay? That's how you figure that out. So looking at the next one then, this gets even more complicated because now we're not increasing by 1s anymore, we're increasing by 4s, right? 4 plus 4 is 8, 8 plus 4 is 12, and then we assume that this kind of continues on. 168 plus 4 is 172. 172 plus 4 is 176. So let's see if we can figure this one out. So we're going to 4 to 176, right? Okay, so this is the sequence that we're starting with, and we want to figure out how many numbers are in this sequence. So since you're increasing by 4 each time, each of these numbers should be divisible by 4, right? Well, not just because you're increasing by 4 each time, but because the first number is divisible by 4 and then you're increasing by 4 each time. So each of the numbers on the list should be divisible by 4. And if I divide through by 4, notice that 4 divided by 4 is 1, 8 divided by 4 is 2, 12 divided by 4 is 3. So I get the list 1, 2, 3, 168 divided by, well, 4 goes into 16 4 times, and then 4 goes into 8 twice, right? So 42, and then 43, and 44. So this is the list that I get. I've divided through by 4. So one way that I can kind of denote that is to say that I factored out of 4. So I'm going to kind of denote it this way. So if I factor out of 4, then this is the list that I'm left over with. But the number of numbers in this new list is the same as the number of numbers in this original list that I started with, right? Only in this new list I can see pretty clearly that there are 44 numbers in the list. So the number of numbers should be 44. Okay, so hopefully you got 44 for that third one. And then the fourth one, 24, 27, 30, it looks like we're increasing by 3's, right? 24 plus 3 is 27, 27 plus 3 is 30, and so forth. And we want to go all the way to 105, so 24 to 105. So it's 24, 27, 30, and then 99, 102, 105, right? Since we're increasing by 3's, I'm going to do the same trick that I did up here and factor out a 3. If I factor out a 3, I'll be left with 8, and then 9, and then 10, and then 33, 34, and 35. Okay. But there are not 35 numbers on this list because this list didn't start at 1, it started at 8. And borrowing the idea that I got from this one up here, I know that the number of numbers is going to be this last number minus, this first number minus 1, right? So not 110 minus 5, but 110 minus 4. And in the same way, the number of numbers on this list is going to be this last number minus this first number minus 1. So not 35 minus 8, but 35 minus 7, right? So the number of numbers (35 minus 7), okay, which is 28. So 28 numbers on that list. Okay, so that takes care of that. Now, why do we care about this? Well, we care about this because when we're trying to find the sum of a sequence of numbers using Gauss's method, we have to know how many numbers are on the list, right? So we did a bunch like this first one on Thursday. Let's just refresh our memory about how that goes, and then we'll do the second one as well. So we want to add up all the numbers between 1 and 104. Okay. So we're going to add up 1 plus 2 plus 3 plus 102 plus 103 plus 104. Okay? And you may know a formula for this, but I'm not asking you to use the formula. I asked you to use Gauss's method for this. So Gauss's method would tell us, so the way that Gauss did this, the legend goes, that he took this same list and added it to itself. So he doubled it, okay? But when he doubled it, he wrote it down backwards, right? So instead of going 1, 2, 3, 4, 5 all the way up to 104, he did 104 plus 103 plus 102, like this. And the reason he did that is because when you add these together now, you get 105, right? 1 plus 104 is 105. 2 plus 103 is 105. 3 plus 102 is 105. So you get 105 each time, right? Okay, so in other words, to find this sum, all you have to do is add 105 to itself a bunch of times. Now, how many times? And this is where it's important for us to know how many numbers are on the list. Okay, so on our original list here in black ink, we can tell pretty easily this starts at 1, ends at 104. There must be 104 numbers on the list. So you're adding 105 to itself 104 times. So the sum, right? So the original sum is going to be 105 added to itself 104 times. So 105 times 104, but that's what we got when we doubled the sum, right? So in order to undo the doubling, then we need to divide by 2. Okay, and that's how we find that sum. For the moment, I don't really care what that ends up equaling. Okay, I'm just gonna sort of leave it like that. Okay. So with that in mind, now let's talk about that second addition problem. So we want to add up 14 plus 15 plus 16 all the way up to 104. So almost the same sum that we did before, but this time we're going to start at 14 instead of starting at 1. So here we go. So we want to do 14 plus 15 plus 16 all the way up to 104. Okay. So we can still use Gauss's method on this. Okay. And actually, I want to give you two ways to think about this. So here's one way that you could think about this. So again, using Gauss's method, this is I'm just going to add this to itself backwards. Uh, 16, 15, 14. Okay. When I do that, I get, looks like 118 plus 118 plus 118 a bunch of times. Whoops. So I'm adding 118 to itself a bunch of times. How many times am I adding 118 to itself? Well, it would be 104 minus 13, right? 104 minus 13 times. (104 minus 3 is 101, minus 10 is 91, so 91 times. Okay, so then the original sum is going to be, I'm adding 118 to itself 91 times, but that's twice as much as what my original sum in black ink was, so I divide by 2. To take care of that. And this one, let's see what we get. I'm going to punch this into my calculator. 118 times 91 divided by 2 is 5,369. Okay. Okay, so that's one way that you could do it. Here's another way that you could do it. So we could do this, right? 14 plus 15 plus 16 all the way up to 104. What I could do is I could imagine this kind of the way that I imagined this first list when I was trying to figure out how many numbers are on the list. That is, I could fill in the part that's missing. Okay? If I fill in the part that's missing, I would have 1 plus 2 plus 3 going up to 11 plus 12 plus 13 plus 14. Okay? And then what I'm going to do is I'm going to find the sum of I'm going to find the entire sum of this entire list, and then I'm going to subtract off this part. Okay? I'm going to subtract off the sum of the first 13 numbers. So I find the sum of the entire list, and then I subtract off the first part, and that'll get me what's left over. Okay? So so the sum of the entire list I just did, right? I just did in the previous problem. And you know, I suppose I could do it all over again, but I mean, I just did it, right? So it's 105 times 104 divided by 2. Right, that's the sum of the entire list. What about the sum of the green part? So for just the green part, if I were to add this to itself backwards, 13 plus 12 plus 11 plus 3 plus 2 plus 1, I would get 14, 14, 14. How many times? Well, there are clearly 13 numbers on that list. So I'd be adding 14 to itself 13 times. Okay, so that's the green part that I'm going to subtract off. Okay, so then the sum, so the entire sum, I guess, the entire sum is going to be 105 times 104 divided by 2. Right? And I did that work up here, right? This is just the sum from 1 to 104, 1 to 104. Okay? So it's 105 times 104 divided by 2. but then I need to subtract off the green part because I only care about the sum from 14 to 104. So I'm going to subtract off the green part. That would be 14 times itself 13 times. And again, I've got to divide that by 2. Now, moment of truth, let's see if this ends up being the same as this answer here. So, let's see. 105 times 104 divided by 2 is 5,460 minus 14 times 13 divided by 2 is 91. And then let's see, 5,460 minus 91 is 5,369. Sure enough. Okay. So two different ways that you could do this. You may have thought of other ways to do this as well. That's fine, as long as you're using Gauss's method in some form or another. Like here, the second way, I actually used Gauss's method twice, right? I used it to find the whole thing, and then I used it to find this part, and then I just subtracted the two. Okay, this way I just used Gauss's method a little bit more straightforwardly, I guess. But anyway, as long as you're using Gauss's method to find the sum, I'm happy with it. So that's all I'm going to say about your homework. I'll start a new video and we'll talk a little bit more about these kinds of sums.